All right, guys, section 1.15, limits at infinity. We're going to start this lesson off also with a graph. What we're doing, though, is we're trying to figure out the limit as x approaches infinity or negative infinity. The last video was more about vertical asymptotes. This one's going to be about horizontal asymptotes. Okay, so a limit as x approaches infinity. Think about the x-axis for a second. So if this is 0, positive numbers over here. So as we go further to the right on the x-axis, we're getting closer to x equals infinity. As we go further to the left, that would be x equals negative infinity. So this is really just saying what happens as we go right forever and what happens as we go left forever. In other words, end behavior of the function. All right, so as we go right forever, it looks like this graph is kind of leveling off and getting really close to y equals -3. So that's going to be what the function is approaching, is the value of -3. As we go left forever, right, it looks like there's a horizontal asymptote at +3. All right, so not too difficult from a graph, but one of the main takeaways from this is anytime we're asked for either of these, okay, it's asking for the end behavior, or more likely than not, the horizontal asymptote. All right, and this function had not just one horizontal asymptote, but two, and that can happen as well. We'll get to one like that towards the end of the video. All right, so expressions like this. All right, so we actually did this in AP Pre-Calc. We did, I didn't put it in limit form, but it would say something like find the end behavior or find the horizontal asymptote. All right, so these are both rational functions, polynomials divided by another polynomial. Whenever that happens, whenever x is approaching positive or negative infinity, we're just looking for the horizontal asymptote. So we need the degrees. So this is the case where the degrees are the same. And so we get to, we ignore the lower degree terms, just the highest degree terms that we're looking with or working with. So the x squareds, if we ignore all that, all right, just cross it out. The x squareds essentially cancel, and we're just left with 3/4. All right, so that's our limit as x approaches infinity, 3/4. The next question, the highest order term or the degree in the top is 1. In the denominator, we've got an x to the first and an x to the first, but they're being multiplied. So the degree in the bottom is not 1, it's 2. All right, and anytime that the degree is larger in the denominator, automatically there's a horizontal asymptote at 0. All right, it doesn't matter if you're going right forever or left forever. Same thing on this one. Whenever it's a polynomial divided by a polynomial, there's only going to be one horizontal asymptote. All right, again, there's a case where there's two, but it's not polynomials. We'll get to those in a little bit. Okay, next question. We're looking for the end behavior here as x is moving further to the right. Now, unlike the last questions, we don't have a fraction, at least not at the moment. So I'm going to just take that infinity and plug it in for x. All right, so that's going to give us 2 raised to the negative infinity. Now, you might remember from a previous course that we can get rid of negative exponents. So whenever you have an exponent that's negative, we can create a fraction. You can move all of this into the denominator, but the exponent becomes positive, and whatever goes in the numerator is whatever's in front. So in this case, a 1 divided by the original problem, but with a positive exponent. So we're going to do the same thing here. All right, so we're going to rewrite this as 1 divided by 2 to the positive infinity. Now, 2 to the infinity, that's just 2 times itself forever. So if we multiplied 2 times 2 times 2 times 2 forever, we would get to infinity. All right, so now we're at 1 over infinity, rather. And if we divide 1 by infinity, that's going to give us 0. All right, last one, and this one is pretty tricky. It says find the horizontal asymptotes of this function. Okay. Now, it's not a polynomial over a polynomial. And so when we have a fraction and they're not polynomials, it's not a polynomial because of the square root, we have to check if there's one horizontal asymptote or if there's 2. Okay. So the way we're going to do that is we're going to think through, if I plugged in a positive infinity for both, what do I get? And if I plugged in a negative infinity for both, what do I get? So if I plugged in a positive infinity, right, we get this right here for both the x's. All right, so squaring infinity, multiplying it by itself, it's still infinity. Adding 3, it's still infinity. Even when you square infinity, it's still infinity. So we get infinity over infinity, which, believe it or not, is not necessarily 1. It might be. We're going to come back and figure that out later. But the point is, we got a positive number over a positive number. Okay? And it didn't even have to be infinity. It just needed to be a large positive number that I plugged in. Okay? So we got a positive over a positive, which is a positive. Now, if I did the same thing with a negative number, okay, and I'm just using infinity, but again, really any negative, like large negative number would work here. All right, so now if we simplify, if I square negative infinity, I'm going to get positive infinity. So I get the square root of infinity plus 3 over negative infinity. Add 3 to infinity, it's still infinity. Square root it is still infinity. But now we end up with a positive infinity over a negative infinity, which is going to give us a negative number. Negative number. So that tells us there's actually 2 different horizontal asymptotes. One's going to be positive, one's going to be negative. The way that we find those, I'm going to show us a shortcut. The real way is very complicated. But kind of a shortcut here is, even though it's not a polynomial on top, if we ignore that 3 because it's not the largest exponent, we can turn this into a polynomial over a polynomial. And what does it turn into? Well, the square root of x squared is just x, and x divided by x is just 1. So this sort of simplifies into 1, positive 1. However, because we know that when we plug in a positive infinity, we get a positive number, and when we plug in a negative infinity, we get a negative number, our asymptotes are actually going to be at y equals plus or minus that number of 1. Okay? That's it, guys. Stay flawless.